Hi, hello, everyone. Hello, student. Hello, can you hear me?
Yes, we
Yes,
can.
ma'am.
Okay, can you see my screen?
Yes, we can see your screen.
Thank you. All right. Okay, let's get started with lecture 2 today. I've seen how many of us here. Okay, let's wait for another 2 minutes because I'm seeing your friends are joining. While we are waiting for your friends, is there any questions from the last lecture? Yes, no, no, yes. All right. Then can we recall the the class norm that I shared last week? First, camera is on. For the tutorials, do we not go through the entire worksheet? I'm sorry, Nikon, which program are you from? So ESE, so please check with Prof. Sabu on this. So all the tutorials and assignment projects will be handled by the prof in charge for the program. Even the difficulty level of the tutorial is also decided by the prof in charge. Okay, so SPE student, be check with me. For other programs, be check with Prof Lee, Prof Sabu, and Prof Siva. Okay, before we start, let me start record our session. Let me see. All right. So far, do you know how to? Wait a minute. Sorry. Wait a minute. I need to sign out from this first because if not, it will cause issue. All right. Now give me a minute. I set up the system again. Okay. Now let me record this our session before we start.
Recording in progress.
This is recording now. So let's get started with today's lecture. So today's lecture is we start to work on real things about programming. We'll talk about algorithms, and we will go into the control structures of C. So we'll get started with very basic structure, which is if else, nested if else for a selection. And then we also go into repetition statement. We will use while to do repetitions for the program to set the program to do a repetition. And we will learn how to use the counter control and sentinel control mechanism to control the repetition. And finally, we'll start to learn more operators in C, which is assignment, increment, and decrement. Okay, so this is the plan for today. So we have gave 10 minutes break 3 times. Hopefully we don't need so much of that, and I will use this 10 minutes break to for Q&A actually. So first we will work on the algorithms. We will learn about what does it mean by algorithms, why we need to develop this before we actually write a program. And then we'll start on with the if, else, and while statements. And from that, we will learn how to use these statements in our program. And finally, the operators. All right. Now, first of all, algorithms. So what is algorithms? Can anyone tell me what is an algorithm is? What an algorithm is? It is already in the lecture notes, right? So basically, algorithm is actually your solution, the solution that you have in mind, and you need to go come up with that to solve any problem before you can tell or you can instruct the computer to do it through your program. So let's get started with the solutioning workflow. So first, for any problem, what do we have? We always have some objectives. We create a program for certain objective, right? We will need to do computation, or we'll need to print out something, or we'll need to transform certain thing. So the objectives is actually usually written in the questions. And then the inputs and outputs, what do you need to take in? Will you take in numbers? What type numbers that you need to take in? And the outputs, what do you need to produce? What the program need to produce? And finally, what are other constraints that you need to consider? For example, the input cannot be less than 0 or something like that. So this is the whole thing here is so-called the definition of a problem. So any problem, when you read the problem statement carefully, you will need to be able to map those words into objective. What do I need to do? What the program need to do? What are the inputs that I need to take in? What are the outputs that the program need to produce? What constraint that I need to take care of? So this is in terms of problem. So after you understand the problem, then you can start to work out a solution. All right. So in terms of solutioning, it is a set of actions that the program need to execute or the computer need to execute. And these actions need to be placed in sequence or in order because computer will take in your instruction line by line and do it sequentially. So you need to be able to sequence your action properly so that it can allow the computer to do it properly and finally generate the result as what you want. Okay. And finally, after you come up with a solution, you come up with a strategy how to solve it, then you convert it into a program. So in this case, you can use C to write the program, right? Or if you are familiar with Python, you can use it. You can use C sharp, C++, C sharp, or Visual Basic. So solution is a strategy or the methodology for you to solve a problem. So the word algorithms here, why is it so important? Because it is the start of your computer program. Without an algorithm, you cannot really write a program properly. Okay, and the definition of algorithms is by textbook like this: a procedure for solving a problems in terms of actions to be executed and in the order. It needs to be placed in a correct order. If not, the result will be wrong. Okay, so I pause here. I put my question here. Can a programming problem be solved without an algorithm or not? Yes or no?
No.
Without an algorithm, it means that you don't know how to solve it yourself. So if you don't know how to solve a problem yourself, how can you teach the computer to solve it, right? So you need to have that so-called algorithm, whether you written it out very clearly in certain form or it's still in your mind, but you do have a strategy. So whatever you have in mind is so-called an algorithm. All right. But in this such lesson today, I will share with you how we can document your solution approach so that other can understand and it can be used for different language. Okay. So take an example of very basic. This is from the textbook that we have. This is an example of algorithm rise and shine in the morning. So the first step, we need to get out of the bed, take off pajamas, take a shower, get dressed, eat breakfast, and take a carbon to work. In our case, usually we take bus or MRT to school, right? So let's say if we swap the orders here. We change the order. Instead of taking shower before get dressed, we will do opposite. We will get stressed first and then take a shower. Then what will happen? What will be the result? You get this. You will get wet. After you get dressed already, you take a shower. Without the step that preparation step, then you get wet. So this example is very simple to tell you that the order of the instruction is very crucial for computer because it will analyze and perform the instruction line by line. So if you place the instruction in the wrong order, the result will get wrong. Okay. Sometimes it may affect, sometimes, but it may not affect because it doesn't depend on each other. But it's crucial, like dependence instruction. You need to be careful and make sure that they are in the correct order. Now, move on to the tool for us to represent our algorithms or whatever solutioning that you have in mind. So you have some idea to solve some problem, right? Now, how can you describe that so that another friend or another programmer can understand it? What kind of tool that you usually use so far? Any idea? No, you don't have any tool. Or we use commands in a program, but this step is even before we get into any programming language. So we will use two types of tools that usually are useful for us to describe what our algorithm is. The first one is pseudocode. The second is flowchart, which is both of them will be covered in this session. So pseudocode is by the name it tells you already. So-called is a fact code, so it doesn't follow any language yet, but it will yes, MyMath also one stage, but MyMath usually at the higher level, it at the algorithm level. Pseudocode is a lower level, it's more towards programming. So MyMath is more at the solutioning stage. Okay, so I go into this for you. So pseudocode is actually a step-by-step description of an algorithm. And it doesn't follow any programming language so that it doesn't tie with any notation. Usually we use plain language, English language in pseudocode. The reason that we don't tie it to any programming language because it will allow the readers or your teammate to understand it without the need of understand any specific language. So for example, later in a team, right, you may know C. So your friend, you may know C, you work with hardware. So your teammate may know, for example, JavaScript, working with cloud system. All right. All right. Someone will know, like, for example, Python, working with machine learning. All right. So your teammate may not know the notation of C language. So if you use any language notation in pseudocode, your teammate cannot understand, and they cannot collaborate with you in a project. So pseudocode is the main purpose of pseudocode is sit in between the algorithm and the programs in a very programming language, a neutral way, so that it can be implemented in any language. So I can use C to implement a pseudocode. I also can use Python or any other language to write it. Doesn't matter. But no matter what language I use, I still if I follow your pseudocode properly, I still can generate the same result. So that is the purpose of pseudocode. Okay? No matter what language is used to implement the pseudocode, if it is implemented properly, the result will be the same. So that is a requirement of pseudocode. No programming language specific. Okay, and the main purpose of pseudocode is for us to understand our solutioning strategy and for better collaboration. Okay, so some of the requirement for us when we write a pseudocode. First, we only include action statement. For example, usually start with a verb. For example, get input, set A equal to B plus 1, or it can be prompt the user to enter input or print the result. So it will start with all the verbs because it contains action statement. So action needs to start with verb, right? And then second, it needs to be presented in a structured manner, meaning that whether you want to number it so that we can know what is before what, or you can indent the statement to know, especially when we have the structure like if or while later on, it needs to be indented so that we know which one belongs to which. And finally, the things that I want to emphasize here is a variable definitions is not included in pseudocode because it is very it depends on the programmer, how they can define it, how he wants to use the memories. So it is not a action. It is preparation setup. So we don't include variable definition in pseudocode because it's just a preparation of a memory. Remember, variables is actually a memory container for us to store input or an intermediate output. Okay, and then it depends on how big, how small you want the memory is, how fast or how slow you want it. So it is up to you to decide it. Okay. Yes, in real life, definitely we use multiple language on our project. We can use different language for front end, different language for back end, different language for cloud, and different language for desktop version also. So what the other language should be able to understand each other program well. The way the only means for other team can understand certain other teams solution is through these kind of representation of algorithms. So you learn about pseudocode and flowchart. So usually before the coding is done by the team specifically, but when we discuss a solution, we will use this, for example, flowchart to get the higher level overall picture first. And when we go to detail level, usually we use pseudocode. So we can use hybrid, but I will explain more after I go through pseudocode and flowchart. Both of them, I will explain more. Okay. So first of all, pseudocode is usually used at the lowest level because the requirement, the nice thing for pseudocode is if any need, is very similar to English, and we can write to the level of details that one line in pseudocode can be easily converted into one statement in any program, computer program. So this is a level of details we can achieve through pseudocode. We may find it very difficult if we use flowchart later on because it may take a lot of space. So we can combine these two in a big project. Okay. So previously, when I work in the industry, my team front end, they use different language, back end use a different language, and the way we communicate is sometimes something like this: flowchart. This input, this and this and this and this, and in each box of action, it will convert into a smaller program, and in that smaller program, we start to work out the pseudocode for that smaller program or smaller function. Okay. So how to develop pseudocodes? Actually, for any algorithms, we need to start top down. We think of big picture first. What is objective? What is input output? And then we work out actions. In each action, we work out the main things first, and then add in the detail later. I will go through into the step later on through an example. But for now, you just know that for us to develop pseudocodes or any algorithm, we definitely need to start from somewhere, and we start from the big action first. For example, if we want to do a calculation of two numbers, so action calculation of two numbers, right? So we break it down how to do this. So step one, you need to get the number in. Step two, you need to check or something like that. So start from the big one and then slowly break it down until the level that each of the lines in your pseudocode will be equal to one statement in your program. So that is the level of details we need in pseudocode. And then some common structure constructs that you can use in your pseudocode. Just now I said start and end. You can use for input and output. You can use the input, read, get, print, from. This is something you can follow. And for process, you can say if you can use those actions. What, for example, set, calculate, increase, subtract, divide, or check, something like this. And then if you want to include any decision, you can use if else. We will go through it later also. And loops, you can use while or repeat until. So these are the common construct that you can use in your pseudocode. So I pause here. So in exam, this is a requirement that we really need to look in your pseudocode. First, in your pseudocode, we don't include variable definitions because variable definitions is not an action. It is dependent on the way that the programmer want to set up the environment for the computer program to run. Big or small, whether float or double variables is up to the coder to do it. And then second, the pseudocode need to be detailed at the level that each line in the pseudocode need to be equal to one statement in C. And then you need to start with action words like this. Now, example pseudocode. These are some examples. So the first example is just for you to get if you want to write, for example, pseudocode for a robot to know how to cross the street at a traffic light. It's something like this. So it's not for human being. Something, imagine that you need to write this program for your robot to wait and cross the street, right? So first it needs to stop at a crossroad. And then it check for the traffic light color. And then you need to have a condition here. After you check, it means that you look and check. And then you need to compare, right? Whether the traffic light is green and countdown timer is enough for us, for the robot to cross or not. If yes, it will cross the street. If not, it will wait until the next screen and then finish. So if you notice this pseudocode, if we write for a robot, it may not be detailed enough because each of the function here may lead to another program. To be honest, right? But at this, assume that this level, you can have the built-in function in the RS system that of the robot that it can do this one line by line. So if you look at this one, first of all, in terms of format, what do you see? What do you see in terms of format of the pseudocode? Format. Format, you see start with action word. Yes, very good. Start and end. Second, now you see that the alignments, indentation. Okay, very well formatted like this. Okay, and then here we don't declare any variable, although there may be a variable here to store the color of the traffic light. When the robot look and see the traffic light, right, it may have a variable to store the colors first. Then it compare, right? But how to know how to indent properly? You just need to write it neatly like this. Or if you in the exam, my tip for my student is bring a ruler and draw and a pencil and then draw a line and follow that. Okay? If you type, you use tab, then you can make sure that everything align properly. Okay? So there's a first thing for you. There are a few things for you to see in this. So the code is first is format, very neat, and then on action word here. And then here, because this cross statement here is inside the condition of the if statement, so it will be indented inside one level inside also. Okay, now let's move on to something more mathematics. So the second example for you to write a pseudocode to do the summation of two numbers. So for example, this question is write a pseudocode to calculate the summation of two numbers and display the result. Okay, so if the requirement is like that, you will need to think of, first, I need to get the two numbers from the user. Then I will need to do the calculation. And finally, I will need to print out the result. So basically, there are three steps, right? That's your solution. So then you convert that algorithm into pseudocode by this. Start and end. Inside the first step is input number one, number two. So in pseudocode, the requirement here is usually we write it as a fact code. So requirement is the variable name should be consistent so that it's easier for us to refer to. So for example, I don't need to say that, integer number one, integer number two, int number one, int number two. No, because this depends on the coder. All right, for you can use integer, but another coder, he wants to have a bigger range, he can use long integer. All right, so he want to use bigger memory to store. He want to do calculation for bigger range of numbers. He can use it a bigger memory slot. So we don't include variable definition here. We start with the word input. So when a programmer look at this input statement, depends on the language that he is using. He will use a proper statement to do it. For example, for C, we need to do scanf to get input, right? But in Python, we don't use scanf to get input, right? So that's a key point here. We just need the statement that input number one and number two. That's it. And then we see that if we use C to do, we will use the function scanf. After that, we set as sum equal to number one plus number two. With this, in C, we usually use our set, shorter, faster for you to write in exam room. And we talk about action words. So set. So in this case, in C, we just need a statement sum equal to number one plus number two, and then semicolon. But in Python, we don't need that semicolon, right? And finally, we need to bring the result. We just say print sum, okay? Then in C, we will write printf % sum, okay? Something like that, and then finish. So this is a very simple example of what a pseudocode look like, and it can be used for any language. Okay. Now, what is some of the good practice for us to use when we develop pseudocode? First, we need to use naming convention, as I just shared just now. When you use number 1 and number 2 here, we should refer to it exactly in any other statement, so that when the other programmer read your pseudocode, he knows that here you refer to number 1, not another number. Okay. And then second, you use verbs to describe action. Capitalize the construct key. For example, if else statement, for example, like this. For me, I usually capitalized the action word. For you, it's okay if you don't capitalize the construction. Just need to capitalize. For example, if else, why, do, why, or for. No, we don't use for in pseudocode. Those like repetition and decision making construct will do. And next, we will need to make sure that one construct per line. We don't include everything into one line, huh? Probe tested in any quiz test or record. Yes, CC1 content for all exam, on assessment. Okay, because it's a key for you. It's a first step for you to really work out your program. If you cannot analyze a problem and cannot come up with your solution strategy, you cannot develop your program. That's why pseudocodes and flowchart also algorithms will be tested in all assessment, including projects. And I continue on. And next thing, we need to indent properly. And importantly, don't write it in any programming language. As I said, your teammate may not know C. He may only know other language, so he cannot understand the pseudocode in a specific language, programming language. Okay, so I pause here. Any questions about pseudocode? No, actually, it's not about you memorize. It is common words that we can use for a very common statement. I go back to here, right? Well, common statements in a very typical C program. For example, in any C program, you do need to get certain input, right? When you need when you get input from the user, so what is a common keyword action words you can use? Is something like this. So you can use it, or you can come up with any better word, nicer word. Also okay, but these are the common words that it can be easily understood by any reader. Okay. Then the process is really depends on the action that you want the program to do. In this case, for example, set is mean assignment. We assign this to what value. We calculate, it means we compute certain thing, we increase, we subtract, we decrease, we convert or something. So these are the things that it really depends on the process that you want to use. If else statement and repeat is a standard structure already, construct already. It is there, and when it is really for decision making and repetition. So only these two is compulsory, not a compulsory, but you need to remember. That's it. Okay. So far, any question about pseudocode? No, right? So let's work on this example. So is this a good pseudocode? Is there any issue with this? Which one? Which one is not good? It's not all use integer. Okay. So this one, the first one, as I said, the declaration doesn't need to include it in the pseudocode. Okay, so you don't need this. Second, indentation, yes, because if statement here, if it is not equal to 0, right, then this one need set result equal to the number 1 divided by number 2. This statement need to be indented one more level because it's the statement after the if statement. Only when the if statement here is true, then we will perform this. Okay, and this two need to be indented, sorry. So these two need to be indented. Wow. All right. Anything else is good to go already, right? Okay, yes, not equal to this one also, because this one very specific to C. If you use C sharp, it's a different notation actually, a different syntax. If you use, all right, so this one very programming language specific. So this one you also need to avoid. So with this, we will convert it into something that more so-called English friendly. By this, we don't need the integer here. We start with input because why we need input? Because we need the user to give us the two numbers, right? And then we need to check whether it is not equal to 0 or not. And then if yes, it is true, then we will do this too. If not, we do this and else. So this one, optional. As long as your indentation is well laid out, is neat enough, you may not need to include the else here. The purpose of else is for easy for easy reading because sometimes your pseudocode is very long with a lot of if else. So usually we include an else or n while or something so that we can know which one with else that we referring to. But in this case, if the pseudocode is very short and then the indentation is well done already, you may not need the n else here. But it's a good practice for you to put an end of any construct inside it. Okay? Is it okay, Joseph? All
Yes,
right.
ma'am.
All right. Any questions? Now let's move on. If not, let's move on to flowchart. So you know, pseudocode is very English, plain English, and we just write it a way that we think, but it needs to be details at the level that each line will be converted into one statement in your program, and it needs to be laid out properly, neatly using the indentation. Okay. Now we move to another one. Another method to present your algorithms is flowchart. I believe that this one very familiar with all of you. So far, I believe that most of you have already developed a certain form of flowchart, right? So far. But flowchart, when it is used for algorithms, it will be the same. It is a chart to show the flow of certain things, right? This one is a flowchart. But in programming context, flowcharts need to follow certain requirement. All right. So definition, whatever, I leave it to you because to me it's very easy. It's just a graphical presentation of your algorithms. It is a chart to show the flow of the program. And then in order for us to understand each other in the programming community, we will use this kind of, how to say, notation convention because it is commonly understood by the readers in programming community. So easy terminals mean to determine the start and end of the program. Okay, and then to connect to show the flow of the action from where to where, we will need to use arrows. And remember in C, in any program, usually it is one way direction. So there will be no two-way error because it's a flow. The program needs to flow from A to B. It cannot flow back on the way B to A, all right? So you need to use the arrow, one-way arrow like this to show the flow or the direction or the sequence or the orders of the step in your program. Next one, in order to show what the input or outputs action, then we will use this kind of parallelogram, okay, to show it. This is to distinguish from any process. For example, if you want to get input or print output, you will use this shape. But if you want to do summation, division, or comparison or something, so you need to do this. And this is for us to use for decision. Usually we say check whether yes or no, true or false. Okay? So this is 5 common notations convention for flowchart. And with this, we're very easily for us to convert to flowchart. Okay, so for example, take the preferred example of the pseudocode like this, calculate the division of two inner numbers. So how can we convert to a flowchart? We use this shape, right? The all proud shape. Okay, and then next after the program start, and immediately you can relate to your C language that how to indicate the start of a C program. What is the C statement that to indicate the start of a C program? The main function start here, right? This is where the main function start. Remember? So that's why everything else will be within the main function. This is main, and this is the end of the main. Remember that? So you can relate very easily when you converted this one into C. Now, after you start and input, and because of input, this is the input statement, we will need to use this shape. Okay? And input number 1, number 2. Then now, this is the if statement. It means the decision here. I need to make a decision between this or this, right? And the decision will be this diamond shape. If number 2 is equal to 0, and if it's true, I will, sorry, this is not. This is something wrong here. This is not equal to. Okay? It should be not equal to. It is not equal to or different. It should be the shape. Okay, let me check. There should be this shape. This shape, is something, let me see, 10. It should be this shape, okay? If number 2 is not equal to 0, then I can take the result, right? I can take the division. If equal to 0, I cannot do the division already, right? So if it's not equal to 0, then I will do this, and next I will print the result. Okay, so I pause here. Help me to correct this one. A typo error here is not equal to 0. Now, then come to else here. We convert to the else. You see false, we print the error message. And finally, we bring everything to the end here. Okay, so you can see the equivalent, line by line equivalent with shape, the line and the shape and the flow of the between the pseudocode and the flowchart. Yes. So you can see the start and end here will be equal to your integer main and the end, the return here, and finish the closing of the body here. So everything else will be in between the body of the main function. So very easy for us to write the C code later on. Here you can see that prompt and scan. You may not need to prompt also. If you don't want to prompt, you just start there and then you scanning. All right, and then you check. We will through the if statement later on, and then you will know how to implement this pseudocode into C code later. Okay, so far, any questions about pseudocode and flowchart? Any questions? Is print supposed to be, print is output. Yeah, this one should be like this. Okay, correct. But actually, in this case, you can consider this action because it doesn't show any output. Okay, but yes, to be true, this one should be an output shape. Thank you, Eugene. But this one, when it bring out any result, it definitely need to be a output shape. Okay. Now, if no, what is the pros and cons between flowchart and pseudocode? So what is the pros and cons between these two methods? Both of them are used to represent your solutioning strategy, right? The way you solve the problem. But what is the pros and cons between this? Which is more common in the community, the programming community? Both of them are have certain pros and cons in different way, right? First, in terms of visual, easy to read, easy to understand the code, flowchart will be better because it show directly the flow, right? And you can see easily, well, which one first, which one later. But flowchart will take time for you to draw and very tough for you to change. If you want to add in one more step in between, it's very tough for you to edit an entire graph, right? On the other hand, pseudocode is easier for you to write, easy for you to amend. If you have any change, very easy to incorporate that into your pseudocode. Just add a new line, indent, outdent later on, right? That's it. But the challenge for pseudocode is it's tough for us to, especially for those who are not very familiar with the sequence, the order of the execution, may get lost in between of those texts here. Okay, so how we usually do in practice, usually at the very high level, to show the dependency between, for example, different modules, different functions. We will use flowchart because it's easier for us to see whether the flows between this module 1 to module 2 to module 3, there's an interaction between different modules is reasonable or not. It's a high level. All right. Then the lower level at the function level, then we will use pseudocodes because it's easy for us to go to the level of line by line conversion. So I am not too sure about the project that you have in your program, but I always encourage the student that if possible, try to use both of them and see how you can cooperate these two in a so-called hybrid method to best present your algorithm. Especially for the group project later, it is more complicated. You may consider use a flowchart first to show module 1, module 2, module 3, module 4 or something. Then in each of that, you see that for function 1, module 1 supported by function 1, and the algorithm for function 1 is like this. Okay? All right. Now let's move. Let's move on to one other thing. Now example. So for example, we have now I show example for you to see the flow between algorithm flowchart, pseudocode and flowchart. In the example, for example, we have an algorithm to do the summation of two numbers input by the user, right? So this is your thought process. Step 1, step 2, step 3, step 4, like this. Okay, this is your thought process. Very lame English of based and no indentation, nothing. All right. Now, this is a pseudocode that we usually use. Neater, easier to follow by any coder. And finally, this is a flowchart. So you see the difference. So in algorithm, you can use the longer the English. And you if you want to better explain your idea. But in pseudocode, try to make it concise enough so that we can convert it into C language or any other language statements. Okay, now let's move on. Sorry, I'm finished pseudocode and flowchart already. By right, we need to have a break here. Do you need a break? Okay, let's have 5 minutes break. And then at the same time, I will take Q&A. So let's come back at 12:50. 4 minutes break. Is it okay? Okay, let me see. 4 minute break. Yes or no? Yes. How about the rest? I only see a few camera here. Let me see. So many don't turn on camera. I will take some name to call if you don't turn camera on your camera. Okay, let's continue with control structures today. Okay, so we will need to use this in our program to make it more efficient. So far we have learned a few things only, like we have learned to write a program to read some input, do some very simple calculations, comparison, and then print out the result. But actually, the capacity of programming a computer program is much more than that. And we do have a lot of structures for us to use so that we can instruct computer to work more efficiently compared with to us. Okay. And in this second portion of today's lecture is about this. We start with a few structures that we can use in C. Now, first of all, what is a control structures in C? Control structure is actually something that's specifically designed the way that when the compiler read on this, it will instruct the program to perform in certain way. Now, if there is nothing directly instructed using these structures, any C program will run sequentially. It means that it will read top down. Whatever on top will be executed first, and it go top down. It doesn't if you don't have any different instruction to the machine to execute it differently. And for example, previously when last week we already learned how to read into numbers, right? When you write a print statement like before, write a prompt statement like input two numbers, then that message will be displayed first before it scan in, it read in any numbers, right? So this is something about C. C is always do sequentially if there's no specifically instruction differently. Now, for example, in this case, you see if we write a program to get two numbers, right? Assign the two values and two numbers, and we calculate the sum, we calculate difference, and then it will do on the printout like this. So this one we will have the but compare with this, there's no in this program there's no other options, right? Always top down, there's no branching, nothing. But in this program we don't have this kind of thing specifically. We have this way or this way. If it's true, if it's true, if it's true, then we do this. If it's not true, we do it differently. So this is something not this flow is not something not very sequentially done in C, and we need special structures to do that. And the following subsections in today and next week we'll learn about on these structures, how to instruct C to do non-sequentially or to do branching or repetition. Okay. Now, just a bare definition. I don't think you need to. I will need to explain on this very carefully because I believe that after you learn it and the structure, you understand on this definition. So basically, in C, there are three types of constraint statement that we can use. The first thing is we use for selection or branching. It means that we can, if we want to make decision, if something is true, we do this. If not true, we do another one. Or if something true, we do this. Not true, we don't do anything, we just exit. Okay, so we have the whole branching or selection statement that we can use. So we start with if else, if. We call it the nested if else, and finally the switch statement for us to select a case in multiple alternatives. All right. And second, we also have a structure for repetition. It means that if we want the computer do something again and again and again and again, then how we can instruct the computer to do that? We will use while and do while or for to instruct the computer for repetition. And finally, we have the jump statement. You use break and continue. We don't have go to in C because we don't want to make the code very jumbled. So in C, we don't have go to, and other language may have go to structure, construct also. So in C, we have break and continue to control whether we continue certain repetition or not, or we skip it. We will learn it more next week. Okay. So today, what we will learn this. Today, what we learn? Today, we will stop at this and this only. So you learn a bit of selections and a bit of repetitions. So it's enough for you to do a simple problem. Then next week we'll cover with switch, do, while, for, break, and continue. Okay. Now this is your overall of control structure. I believe that you will know it later. For sure. Very clear. Now let's move on to the selection statement. Okay. What is selection statement? Selections is mean we choose between different options, right? But the outcome is only one. It means I only do one option out of the rest. So the first option, the first statement is a single if, only if. So if the condition is true, then I do this. If not true, I don't do anything. Okay, so this is a flow chart, and this is the syntax of the if statement. Example is like this. Okay, if grade equal to 60, greater than 60, print pass. If not, we don't do anything. So if we stop like this, it will not do anything. All right. So let's put up the pseudocode, and we'll try this one out to see how this works. Now let's start empty file first. And the first step I will do after I start a file is save file, right? Now I save file like, for example, demo 02. Okay, accept, exit already, yes. Okay. Now, what is the first statement I need to do to include in my program if I need to print a message? Do you still remember? Include, yes, include standard io.h. Remember this. Now, what is the statement for us to indicate the start of the program? Teacher? And boy, okay. Sorry, don't see. Okay, now, and then return, put a return here, 0 here first. Now, this is a basic setup of any program, okay? Any program is a basic setup of any program. So I hope you can set up this one before you code anything. Build a habit that set up this key thing in your program before you code anything. Now, let's say we want to we want to check out this code, selection code, right? Let's say assuming that we'll get input from the user, okay? Get input from user, okay? So if we get input, what do we need? If you set up a program that get the input, so what do we need? So to set up first, so that we can store the input. What do you need to set? What do you need to set up in your program so that you can store the input?
Yeah.
Variable, yes, because in order to store any input, you will need a memory slot, right? You need a memory. That's why you need to get to set up the variables. So in this case, what number do you want to handle? Do you want to handle in the whole numbers, or do you want to handle decimal numbers? It's up to you, right? For example, in this case, I handle integer only. Okay, so I handle integer, I call it crate. For example, in other case, you can handle, if you want to have to allow for decimal crate, you can change integer to float. Okay, so get input from user. I can prompt also to let a user know what to do. But if I don't want to prompt, I just put a scanf there, and doesn't matter also, because a program will stop there for us to key in the number, right? Now, for example, I just do a scanf. I don't need to prompt anything. And if I want to read in an integer number, what specifier do I need to use? Percent? D. Okay. And then what is it here? What the second parameter? And rate. Remember n. Okay. Now I need to check. Now I put it here. This condition. Check rate. Check for grade. Greater or equal to 60, right? Now, if grade greater equal 60, okay? In this case, what we do in F pass, okay? Now, let's run this to see what happened. Where is my, yeah, here. If you don't prompt anything, right, when you run, the first thing is pause at scanf. And remember, the tip for you to remember scanf, I am waiting for you to give me an input. And in this case, the input I'm waiting for is %d, means an integer, right? So it means that you see the cursor flashing here it means that the program is waiting for us to key in an integer. Okay, for example, we put in 68. Enter, and it is passed, right? And after it's passed here, it's return. Return 0 means the end of the main function already. And the program will be terminated. Okay? Now, in this, if we put in something differently, we run it again. And if we key in something less than 60 to see what happened. Now, if we key in, for example, 58, what will happen in this case? Nothing happened because there is no else here. If this one is true, then I will print. If it's not true, then I don't do anything. That is mean by the single if statement like this. It doesn't have an else there. So here, if this is the grade is not greater than 60, it will not do anything. It just continue then with the next statement, which is a return 0. Okay? Then it escape. Okay? Now, if you want to have another branch that if the grade is if it's true, I do this. If it's false, I do something else. So what should be the structure that we use? We need to include an else, right? Very commonly in English, we say if and else, right? So if we include an else here, then we set up printf, and then once it fail, for example, and in this case, if I include the else, so will the program print out fail if I key in 58 or not? That's what we expected, all right? So let's see how it works. Now, we put 58 again and see it, and it bring out fail, okay? Now, with this example, I also just explain to you how the if-else statements work, okay? For the if statement alone, it will execute the the statement inside this body, only the condition is true. If the condition is false, it will not do anything. But with the else here, it will do the branching. If the condition is false, it will do this. And it's come to this. Okay? This is the condition true, do this statement, and false is doing another statement. So within this body here, it can have one or multiple statement. It depends on the nature of the program. Okay? Now I'm pausing. Any question about if and if else? Okay? No? Yes? So for if else, we have the same thing, right? Condition is true, I will do this. If it's false, I will do this. Yes?
Professor, they say when I enter the else, right, they says the error shows that it's without a previous if. What am I doing wrong?
Why if statement no semicolon to this? I don't see your first of all about the error, because I don't see your code, so I don't know what kind of syntax error is there. Second, why why the if statement there's no semicolon after this, right? Ryan asked this. You know, the whole thing here we call structure is no longer a statement. These are special structure. The entire thing here is structure. So you don't have the semicolon in the structure because this is how the language set it up. Okay? If you put a semicolon here, the whole thing here will consider this is one statement, and it will not execute the below here. Okay? So in order for you to make this if-else statement a structure, remember don't include semicolon. Semicolon only applicable for function statement like this. But if else or while or do repetition loop is a control structure. They are not statement. Okay? So it can include multiple statements in its body. So there is no semicolon here. Remember that? Now if you put a semicolon here, it will finish this. The whole thing here will not do anything. It will not do anything, and it will escape immediately after it do the checking here. Because it will not consider this statement, the printf statement, is a part of the checking of the if structure. Get it? So try it out here. See, there is an error here because of the else. So let's say I don't have an else here. Okay, so there is no, if I don't have an else here, there is no so-called syntax error. Okay, but if I still put in the number from 68, what I expect is the message to be printed out is pass, right? But in this case, nothing is printed out. Oops, it's still inside. Oh, sorry, I didn't build it again. Now, let me build it again. Okay, so in this case, this printf message always happen. Okay, let me try for you. If I print out something that less than 58, the printf message always print out because it consider the printf here is a standalone statement compared with if. For example, I put in 58 here. I expect that nothing print out, right? But the thing still print out here. You see that? Because the printf is standalone compared with the if statement here. That's why when you bring it back, you will specify that the printf only executed when this statement is true. Now I run it again, and in this case, if I input 58 here, there's nothing print out because the statement was wrong already. Now get it? Now we finish if else statement. Now let's say if we have so many options, what can we do with so many options? So if we have only one option, if it's true, I do something, but if it is false, I don't do anything. So this is the meaning of if. Then we move on to if else. So in if else, if it is true, if the condition is true, I will do certain thing. If the condition is false, I will do something else. And this means that there are only two options for me to choose. All right. Now, if I have so many other options, if it's true, if not, I need check another condition. You check another condition. Then how can we do? Now, in this case, let's say we can have the grade cannot be just pass and fail, right? It can be A, B, C, D, right? So how can we do that? We will need to use another structure called nested if else. It means that we just nest everything. If else, if else, if else. Okay? So we just continue to list all the condition like that until you hit the last options. Okay, so for example, in this case, if you have to do code that if the student grade is greater than or equal to 90, you print A. If it's not, you check another condition that whether it is 80 or not, it's B. And then if not, then you check whether it's 70 and then you print C. And then 60, you print D or F. So there's so many options for you to choose from, right? And in this case, one if else is not enough. And you can use multiple if else in this. Like if greater than 90, grade is greater than 90, put equal to printf in this case. Okay, so then another statement for you to display a message to the screen is put. Okay, it's a new statement for you to learn only. It's a one statement for you to display text and character to the screen. It's a put. Okay, if you want to just display a message to the screen, you can use puts or printf easily. But if you want to display a value of some variable to the screen, you must use printf. So this is the main difference between puts and printf. Now, continue with if. So the next L, the first L is this. So if it is not greater than or equal to 90, the next condition I need to check is this. And then if it's true, I will do the printf of B. Does the sequence of print matters? In this case, yes, it's matter because it allows you to stay only one condition here. But it doesn't matter, you need to combine conditions. Okay? Because in this way, I can jump here. For example, here 90, right? I check this portion first. Then if it's false, I jump another one 80 here. And next one is 70 here. This is how I check. So this is depends on how you smartly place your algorithms. If you don't place it in order, especially when you do multiple checking like this, it's better do in sequence so that you don't need to combine different condition here. If not, you need to combine, right? Because B need to be between 70 and 80. If you don't combine, you need to include another N here, create greater than 70. Then only between 70 and 80 is part under B. Anything between 60 and 70 is C. And anything above 60 to 70 is D. And then below and that is fail. All right. So in this way, you don't need to, because you have already laid out in sequence, you don't need to include another condition here. All right. So next thing, when I write this one, it can be nicely laid out like this, also good. But you can write in this way also okay. If, else, if, else, if, else, if, else, if. Okay, so in terms of format, what do you see the difference between these two versions? In terms of format, which one is, what is the main difference? Less indenting, yes. Second, monitor, which one is neater? Left or right? Rewriting or see the right one? Okay. Okay, so this one neater, right? But you can only use this when there is only one. Sorry, see, let me check it. I erase something here. It's easier for you, huh? So you can only use this if you notice on the right hand side you don't have any like curly bracket here, right? Curly bracket here. That's what it makes it better. But the only case that you can omit the curly bracket to indicate the body of an if or else statement is when you have only one statement in the body, then you don't need to use a curly bracket. But if you have so many things inside it, you definitely need to use it. If not, the second one will consider as outside of the if statement. Okay? So this is something that you need to take note. Now let's go back to the example here. So for example here, in this case, right, for example, if the grade is greater than 60, I will print out pass. And I want to bring another thing out. I want to bring out a message like this. For example, where is congratulations. For example, like this, congrats, okay? Something like this. Now, but what I mean here is if you passed, if your grade is more than 60, then I will print out a message pass and I will print out another message congrats, all right? If it is wrong, if it's less than 60, there's nothing print out, right? Correct? In this case, because I put the do statement inside the body of if, this is expectation. Now let me run it. Then for example, I put in 68 again. You see, there's two sentence printed out, pass, congratulations here, congrats, okay? Now, if I don't use the body like this, I omit the curly brackets. What happened? No error at all. Print it. But it will print this one will be executed regardless the result of this one, because it's actually, if you control A and then you will go to block in and you will to format, you will see actually the put statement is at the same level of if. It means that the put statement is already independent of the if statement. Then the word congratulate will be printed out regardless of your grade. Try it. Now I will do it again. So if the grade input is, for example, 40, for sure fail, I still have congrats here. See that? I don't have the past because the past statement is inside the if statement. You got it? Now if I run it again and I have another past grade, for example, CTA again, I do have two messages out. Now, do you see the importance of the curly bracket to indicate the body of the structure, the if statement? Sorry, the if structure. Then Control A again, and I have plug in and I format it nicely again. Now everything in place. Now, any question regarding the body, indication of the body of the if statement? So the rule is if you have more than one statement within the true conditions of the if structure constructs, you will need to include the curly bracket to indicate the body of the structure. Similarly to else. Else, same thing. So for example, you bring F, failed, right? And if you want to do more things than that, you will need to include the curly bracket to indicate the body here. You need to bring it here, put it in between, and then I'll put another message here. See you next year, for example. Okay? So the statement here, if this one is less than 60, I will have the two messages to be printed out. That's what my expectation is. And then, for example, I put in 40 here. You see, failed, see you next year. Now, if I don't do that, what does it mean? This put statement will independent of the else condition here. And it will appear even I passed. Let's try it again. Here, for example, put in 68. Now see, the two statement message will be printed. Sorry, where is it? So the two message will be is printed out because of the true of this statement, of this condition. Printf pass, congratulations. But the last one is independent. And after it's finished the if statement, the next statement it will be is executed is this message. Okay? Now is it clear about if else? Any questions so far? Can you put only without printf? As I said, put is used with only text. If you want to put out text to the screen, you can use put. But if you want to print out a value of a variable, you cannot use put because it doesn't have any specifier for us to define whether it's an integer or is it a float. Okay? Now let's get back to the lecture. Now, that's one I just explained this portion for you. The curly brackets to indicate the body of the if statements. Okay, and this one is another way for us to write the if statement. But to me, to be honest, I don't prefer to write in this way because it is tough for us to read, and usually there are multiple statements inside if and else. The body of if and else usually have more than one statement. That's why we seldom use this format. So this one is just another format of the if else construct for you to know. But to be honest, I will prefer this format more because it's easier to read. And it's easier for you to handle. If you want to add one more statement inside, it's easier also. Okay? But this, you just need to know. There's another way for us to present the if-else structure. Okay, and now let's move on to a sample. Okay, let me try. Escape. Let me see how I can escape. Let me see, I need to hide the thing first so that you don't see the result first. Okay, let me bring up it again. Now, this is an example I just prepared for you to practice on the if-else statements, nested if-else. For example, in this problem that you are asked to write a C program to get a user input, and then from there you will classify whether the input is the velocity of the object is at rest or subsonic, supersonic, or hypersonic, depends on these conditions. Okay. So now let's walk through the process for us to come up with the algorithms and then write the pseudocode and then come up with the program, C program. Okay. Now, the very first step in your problem analysis is to identify the input and the process and the output. So this is the framework I use for programming. Now, what is the input for in this problem? Does it need any input or not? User input. What type of the input? Integer? Do you want it to be integer? Up to you, right? It can be integer, it can be decimal, it's up to you. But we know that it is the input. There is input, right? So it can be integer, it can be decimal, up to you. It depends on whether you want to make it integer or decimal number. For me, for example, I use decimal. So that's why I say that declaration of variables is not part of the algorithm because it really depends on the user, right? And depends on the designer of the program. My program doesn't need to be an integer. I can handle this decimal number. See that? Okay, what's the difference between printf percentage hello and printf hello? Okay, percentage s, I will explain more in lecture 5 when we talk about formatted IO. So for now, if you just print out a statement, just you don't need to have percentage s there. Just print out hello world. It will do the job already. Now, next thing, what is the process of this problem? What the process that a computer needs to do? Back to the problem analysis of this problem. What is the process that your program needs to do? Any idea, student? Process, action, not if else here. Yeah, it will check and do comparison, right? Do all kind of comparison, okay? Yeah, finally, what's the output? Does it need to output anything or not? Yes, output a text, right? Depends on the process, text result, okay? Now, this is very high level problem analysis. And what I'm guiding you right now is actually, just now I call a step, the top down or stepwise method. We go from problem analysis, and in the process here, we know that there is a comparison, different types of comparison to check between the input and the different numbers, right? So let's go to the algorithms. So what is the first step in the algorithm that you think about? You should have. What is the first step in your program? Star. Okay, star is the indicator of the program start. But what does it do? The first thing. Yeah, ask the user to put in the input, right? Then what else? After you ask the user to do it, now I'm talking algorithm. I'm not talking about writing a program. Okay? After you ask the user to give you a number, you need to get that number into a variable. Okay? You need to store it so that you can refer to it later. Okay, and after that, you sequentially compare the numbers with the 4 ranges, right? And finally, output from the display the output. So this is algorithms. I call algorithm because I write it in a very layman language. This is my thought process here. Okay? Now, this is algorithm. It's not ready for any programmer to code yet. So you need to move one more step into what? Either pseudocode or flowchart. So in this case, I self-space. I work out the pseudocode. How to work out this? Now, this is how. So we will start and then we prompt user to enter a non-negative velocity because for me, velocity cannot be a negative number, right? After that, I say get v because for me, I will use the v as the name of the velocity. So need to get v because if we prompt and then we don't get, we cannot store the value so that we can do comparison later. Okay? Now, after that, we will perform different kind of comparison here by checking whether it's equal to 0 and then print else print and then that's it. So if you look at this one, it's very easy for you to convert into C program, right? I pause here, any questions? So you can see the flow, right, from top down here, from problem analysis. At a very high level, you just know, oh, I need to compare certain thing. Now, what is it? I know that I need to do sequentially comparison because I don't need to have a combined condition in this if statement. I just chunk it out and do the comparison. Okay, and after that, I will convert into pseudocode using those kind of action keywords and the structure here. Oh, in this case, yes, because it's very common language. It can be used in this case. Because in your math, you also use this sign, right, Joseph? So this we can use. This sign we can use because it is commonly understood in math. Only this one is not commonly understood. Actually, for different, we use this, right, in math. So this one is not understood. This one language specific, but this one is commonly understood. This one also commonly understood. That's why we can use it. Now, with this pseudocode, how can we convert to C codes? So we start the man here. We can prompt it here, but before we can get the value, we need to do some memory setup here, right? And then this one will be scanf, right? And then this one very similar to the pseudocode already. Now let's see how we can do it. See that? We will start with this. Then in this case, I set up the memory first. And then on the way I do the rest. So I will prompt the user to put in a number. I scan it here. I get it using the scanf method, statement, and then if equal to 0, then I can bring exactly this, or I can bring a longer message, depend on the coder, the programmer. Now and then else, and then printf, else if, printf, and then else, and print. Okay? You see one line equal to one statement. You see that? I erased on to show you equivalent. This will equal to this. This will equal to this. This will equal to this. See that? Every line will have one equivalent line in pseudocode, and we will have one equivalent line in the C code. And that is a level that we need in pseudocode. Also, will be faulted if we just write everything in English with no. Yes, it's okay. Doesn't. It's okay to replace the less than or equal to with a plain language English. It's okay. Just that because it's too long for me. That's why I can use this side because it's still understood commonly with this side. Okay. Now, any questions? So your job at home is this slide deck, sorry, that's not a slide. Oh, this example was not included in the original slide because I want you to work on this, follow this. And if you want, you can refer back to recording and work out this yourself again. Okay, at home. I give you all the solution step by step already. Then you work it out and see whether you can do something similar in a similar problem or not. Okay, let me see. What time is it? Now, one thing that you can work out at home is you can modify this code to include the check that user enter the non-negative number. Because in this case, I don't have any way to enforce the user to enter something that non-negative. So there may be the case that the user enter negative number, right? So how can you modify this code to do the check that whether the entered the input number is non-negative or not. And if it's negative, print out an error message. Can you do that at home? Of course, it's for your own practice, okay? But something good for you to start explore more. Can you show version again? Sorry. Okay. So this is the version, just a classification of velocity based on different range. And from there, we can come up with the algorithm, we can come up with pseudocodes. Okay. And then from the pseudocodes, we have the mapping 1-to-1 from pseudocode to C code. Okay. Now, are you okay to move on the next repetition? Next structures is repetition. Now we know about if-else statement, if-else everything. And if you notice that first, anything that done within the body of the if is only once. And there is only one range selected based on the outcome of the conditions. Okay? Remember this one. Only one outcome will be executed. So if it's true, we do this. If it's false, we check again. So every time, only one block of statement is executed depends on the situation of the condition. There is no repetition here. Okay? And if we have only if else, then if it only if, it is done only when the condition is true. But if we have if else, then also if it's done only when the condition are true and it do something else when the condition is false. There's no repetition. There's no repeating of the actions. Now we move on to something that if we want the computer to do something again and again and again, what should I do? What should I use? And the statement that we can use or the structure we use in this case is while. The meaning of while is that I will need you to do something until when this condition is still true, I will need you to do it until it is false. So this is the meaning of repetition. So the idea of repetition is that you know that computer is very efficient in doing repeating work, right? It's faster, much faster than us in doing something that repeatedly. It will take hours for us to do some kind of calculation, maybe like 1,000 times of calculation. But it will take computer just a few seconds to finish that. Okay, so that's why we will come up with the repetition statement or while to make sure we use the efficiency of the computer program. So in this case, we will force the computer to do something. We will check the condition first, and if the condition is true, then the computer will need to do the list of statement again, and then after it do, it will check it, and if it's true, it do it again and again like this. So this is the meaning of repetition. First, the program will check the condition. If the condition is true, then the whole things of inside the whole body of the while loop will be executed. And after we finish, it will check the condition again. And then if it's still true, we continue to do it again and again. Okay? Now let's take a look at the example here. So for example here, if we want to do products, if we have this kind of flowchart, how do we read this flowchart of a while loop? So we have a product and we check the product at less than 100, less than or equal. If this condition is true, we will take the product equal to 3 times the product, and then we check it again. So in C code, we will write like this: while product is less than 100, product is equal to 3 times product. Okay, so for example, if product start at 10, so it will run until the product is more than that. This condition is false and will stop. Okay. Now let's take an example of this in code block to understand this better. Now take an example of dash right. For example, in this case, now we start off. For example, we get started. What number of product that we want to start? So for example, integer product equal to, for example, I start with, for example, 10. Okay. Now 10, and then what I do, while product less than equal to 100, and what I do, product equal to 3 times product. And then Finally, I will print out the print. If I want to print out the final result of value of product, what do I need to use here? If I want to print out products, what specifier do I need to use here?
Percentage D.
Okay, we need to use percentage here, right? And then product. I need to write some text here also, right? Better. The final result is okay. It's better to have some text. I did. Now let's run this. Now you see that why the result of final result product is 27y. Do you get the same result? So what it does here, right? Let me explain it to you here. Let me call this one here. I put it down side by side here for you, huh? So what this does here, let's explain here. So first, round one, okay? And product equal to 10, right? When it start here. When it start here, product equal to 10, right? So the next thing, if we check with this condition, if we check with the condition, right? It is less than 100, right? So the condition is true. If it's true, then it will do what? So that will be equal to 3 times 10 equal to 30. Okay? So the first round. But remember for while loop, right? It doesn't stop at that. It will go back and check the condition again. So what we do here for round 2, if we check again, product equal to, what is the current value of product? 30, right? Is it still less than 100? Yes, so the condition is still true, right? If it's true, so the body will be executed, right? So that will be again equal to 3 times 30, right? Equal to 90. Am I correct? Now, it doesn't stop there, right? It will check again, round 3. Now, product equal to 90. Less than equal to 100. Is it true or false? True, right? So if it's true, then the body will be executed. Product will be equal to 3 times 90 equal to 270, right? Now, round 4. Now, product, the current product is equal to 270. And we need to check again this condition, right? This condition is in the while loop here. Is it true or false? False. Okay? And if what it does? Turn escape, exit while loop. It will not do this anymore. And it's moved to next statement, which is print f. See that? That's why you bring f the final value product A275. Now you see how the while loop is executed. So in this case, it executes 3 times because the condition is true for 3 rounds. Depends on the nature of your problem. It can run like 1 time, 2 times, 3 times, 4 times. Okay? So but you can see the repetition, right? Every time it's finished, the body it will back and check the condition again. So the meaning is until this condition is false, I will keep doing this. Why the condition is true, I will keep doing this again and again and again. Why my weight is still greater than 45, I will keep having diet. I'll keep doing exercise, something like that. There's a meaning. Now, if you want to see it clearer, you can include other statement here to see the result, to see whether it is similar to what the current value is, similar to what we have in our analysis here or not. Okay, so I include the print out of the intermediate value. I expect to see 30, not 90 into this one. Okay, inside the output. Let's see it, whether we can see it or not. Yeah, you see that? So the first run, the current value is 30. The next round is the value is 90. The next round, the value is 270. And because it's 270, go back and check the condition which is wrong. And then finally, the final result is this. I pause here. Any question about while loop or not? So far it is just about repetition when we check in some condition. Any question? Okay, so this is how the while loop works. So for you, what is expected is you don't need, what is expected from you as student when you read any while loop, you need to be able to so-called run the codes without really going into any code blocks and run it. And this table is really for you to work out. Just now I work out for you, right? For example, iteration is equal, in this case, I use product equal to 3. Then can you work out this table? It may basically because I have the product equal to 3, I expect to have like about 5 iteration here. So can we work out this kind of table so that you can understand the repetition nature of this structure? So in the first iteration, what is the value of the product? What is the value of product? What is it? Oh, what is the first value of the product here? Here, integer products equal to
3.
3. So the first value is 3. Now, after the products is equal to 3, right? Now, the while loop kickstart now. It will check the condition, right? It will check this condition. Where is it? Sorry. Where is, sorry. Where is my thing? Wait a minute. I have something wrong with my thing here. Where is my cursor? Here. Okay. So it will check the condition here. So what is it when I compare 3 versus 100? What is the outcome of this condition? True or false? You remember this operator? The result of this operator give you true or false, right? So the result is true or false? Of course it's true, right? True. And then because it's true, this two function will be executed. So it will execute this assignment function here, and then it also print out the value of the products, the current value. So what do we have here? We have 3, the product will be 3 times 3 equal to 9, and the current value of the product will be 9. Okay? Now, go to next round. After the first round, the second round, what is the condition here? Is it true or false? It go back, right? After this, it go back to here. It go back to here and check the condition again. So the condition is true or false? True, because 9 is less than 100, right? Next thing is true, and because it's true, this 2 will be executed. Get it? Now, after finish this, it go back again. Check again. 27 against 100. Still true, right? True. Then, and then the 2 functions inside the body will be executed. Okay, this still true. It's become 81. Now, after 81, it still go back and check. Go back and check. And 81 against 100, is it true or false? True. Then, if it's true, the 2 statements inside will be executed also, right? Then the result will be like this. And then, after this result, it still go back and check. It doesn't know that whether it stop or not. It still go back and check. It's this condition again. And this condition now is become false because 2 for 3 is more than 100 is false. And if it's false, this 2 will be escape, no more. Okay, so this one will skip. And the while loop will be terminated. It will move on to the next one. And if you do properly, if you run this code, then you will have the result something like this. Okay? Now, can we try this in our C code, in our code blocks? Now, let's say I start with 3, right? Just now I start with 3. Same thing, right? I start with 3. And then I don't have I keep the final result here for you also. So the product A. Now let's run it. Let's run it again. Let's run it again to see whether we have the same result or not. Yeah, see that? The current result is 9, 27, 81, 2, 4, 8, 2, 4, 3, and then the final result is this. Okay, with this, I think I have already finished one loop, and I have one last line for loops before we go to the break. Any questions so far?
Prof, how do you get the current values? Is it from line 17 to 20?
Current value?
I only see the final value in my code.
Here, because I include a printf inside the while loop here, you see this? Yeah, do you see this?
Oh, okay. Yeah, I saw it.
This inside here. So
Okay.
in this body, I will do two things. I update the value of product, and then after that, I print out the value. So it needs to pack inside the body so that it will print repeatedly after every iteration.
Okay, thank you.
4 rounds in your sentence in your code. 4 rounds. Where is it? Okay, this one is different already because I changed from this one should be 10. The explanation here is equal to when I have a 10. So it will be similar to this. Okay? But if you want to run with 3, then it's already in your slide. Now go back, play around with this while loop, change the condition, change with different kind of formula here, and see whether you can practice this kind of iteration or not. So it's a standard way for you to understand while loop, okay? And it is tested. For example, we run this one, we ask you what is the value of this kind of thing. So you need to be able to know that what is the final value or how many rounds, how many iterations was it performed. So this I found it is the best way for you to understand while loop. Although it may be time consuming in the beginning, but it's very systematic for you to understand it. Now, any question? If not, we have a 5-minute break and come back at 2. Then we can go to the 2 example for us to know how to control the while loop using counter control and sentinel control. Okay? Oops, sorry. I have one more last slide. Okay, this one is a definition of loop. So I will explain later. Now let's take a break up to 2 and then we come back. Someone was my course only prints at the rest. Your scanf is wrong. Sorry, xin chứ. Tristan, we will work on the pre and post increment later, and then I come to your version later. Okay. All right. Let's get back to the lecture. We still have a long content to cover in today's session. All right. Just now we finished if else, if else, forever else, or we call nested if else. And then we have finished while loop. We can see repetition. So basically, repetition is a very common structure in C because we can make use of the power of computer. And those repetition is actually called loops. And actually, we have 3 different types of loop in C: while loop, do while, and for, and all of them will have the same format of checking for certain condition, and then do the whole body here, and then come back and check again, and continue to do if the condition is true, and it will do until the condition is false. Okay, and then while your while function never stop because your condition is true forever. So it will lead to infinite loop. So one of the major notes that we need to make sure is in any loop, you will need to make sure there is some way somewhere in your code in the body here to change the value of the condition at some point of time so that the loop can be broken out and can be terminated, and it becomes false and it go to the next statement like this. So if those who don't see anything, the while function run forever, it means that your condition is true forever. Okay, so this is something that you need to take note when you use repetition. You make sure that there's something in between the body here to change the value of the condition into false at some point of time. And how to control that? There are 2 ways for us to control, which is we call the mechanism. So one is a counter control mechanism, and second is sentinel control mechanism. And we will go through these 2 methods later on. Okay, subsequently in the 2 case study for us to understand how we can use counter to control the repetition or the loops, and how we can use a sentinel variable to control the termination of a loop. Okay. That's what we call the formulating algorithms here. So how to control repetition. If you change the condition for Jonathan, you say that the condition is greater than. That's why if you use a condition become greater than or equal to 100, your condition is true forever. Because the more you multiply the product with something, that condition become even more true. And that's why your while loop run forever. So it will not print out because it hasn't stopped yet. It hasn't reached the end. That's why we call this infinite loop. Okay. So in this section here, there are two methods for us to control the loop so that we make sure that terminates some point of time and it will not run into the infinite loop. Okay. So the first mechanism we call it counter control, meaning in the layman terms, I will keep doing this for a certain number of times. So I will count. Every time I do, I will count. Round 1, round 2, round 3, round 4 until 5 rounds and I stop. For example, I say I will keep taking medicine for 5 days. Okay, so I will stop exactly after 5 days. I will not do any more regardless. Whatever things happen, I will stop after 5 days. So this is the meaning of counter control. Okay. The second way for us to control any repetition is I keep doing it until something happens. Okay? And that something is sometimes user input or sometimes it is, for example, in this case, the doctor tell me to stop. So the doctor is a user input for external input. It means that the first one is we count within the loop. The second is I will need to wait for some input after the loops to tell me to stop, to tell the machine to stop the loop. Okay, so there's two mechanisms to do that. So for the first one, we will use a counter variable to count. So every time we need to count. Okay, so counter usually start with 0. So before we start the loop, right, the counter is at 0 value, right? No repetition, yes. Then whenever the repetition is run, then you count it, keep counting, keep increasing, and then until it hit the limit, then it will stop. Okay. And for the second, we call sentinel control. We will use a sentinel variable, or sentinel means a special variable. That variable just used to signal the end of a loop only. Okay. For example, in my layman example, like my doctor tell me to stop taking the medicine. Okay, so that signal from my doctor. So the signal usually in our programming context is usually from the user. For example, like user enter some special character from the keyboard, then I will stop it. So usually we'll for that we will use, for example, -1 if all the input need to be positive. So that special variables or input or sentinel variable need to have a very different value, which is different from a valid input from the user, so that we can recognize that, oh, this one is not invalid and I will need to stop. Okay, so how to define a sentinel variable is usually predefined by the programmer, and it will tell you through the message, a communication message with the user. For example, enter a number, enter -1 to stop. So if the user enter -1, you will stop it. If enter a number, any other different number, you continue to do something. Okay? All right, so we go through two examples to see how we can use these two mechanisms to control our repetition. The first case is counter control. Counter meaning that we count the number of iteration and we stop by the time it hits that number. Okay. So the first number is for us, the requirement is for us to develop a program to calculate the average of 10. For example, 10 students here, and we will need to calculate the average of this 10. Okay. So how do you do this? Normally, how do you calculate an average of 10 numbers? So the user will give you a number, you do something, and you will stop getting user input after 10 inputs. Okay. And then you will calculate the average. How do you do this? So this is the idea of the algorithm, right? Need to get input of each of the grade, and then we perform the average calculation and bring out the result. So this is a problem analysis statement. So basically, we will need, there's two ways for you to do this. You will need 10 10 inputs, or you need only you need 10 inputs, but you may need 10 variables, or you need one variable. But if you need 10 variables, then it's easy, right? For you just take these 10 variables and calculate the average is 10 number. But it cannot be scaled up to 100 number or 1,000 number, because you cannot have a bandwidth to declare 100 variables, right? So let's say in this case, I say that I have a 10,000 student, and you cannot declare 10,000 variables to get 10,000 inputs, right? So we need to think of a smarter way, how we can keep doing this, getting input, do something and get another input, reconcile that into the variable. That is the idea. So just back to a very primary level of how we can calculate a total of 10 grades. So first of all, we'll need to get a place to store the sum, right? And then we need to have a way to count how many times that we already get in the input. And then after that, whenever the user give me an input, a grade, I will add into the sum. Okay? Add into the sum. And then I will count the first, the second, how many inputs I already get from the user already. And I will repeat until I get all 10 grades and add it to the sum. And at the end of that, when I finish that 10 times of getting user input already, I will get the sum divided by 10 to get the average. Okay? So this is the idea, because I don't want to declare 10 variables to get 10 inputs. So by right, you can declare 10 variables to store 10 inputs, right? But in this case, we don't use that. We use something more effective for the machine to run. So with that, just illustrate the way we do this. We get the first number, then we get the sum equal to the original value of sum equal to plus the value, and we keep count like this. For like this sum, for example, of 10, these are the 10 grade that I will input to the system, to the program, and I keep doing that until my counter hit 10, and I will stop, and I will calculate the sum, and then from there I calculate the class average. So it means that this will with this kind of solutioning strategy, I will keep getting user input until my counter hit 10, and then from there I will calculate the average. After I get a user input, I will add it to the sum so that I can keep increasing my sum with the new input. Get it? So this is strategy for us to do it in a more effective way. So let's say later on, if the program statement increase to 10,000 input, or even a million inputs, we don't need to declare a million variable to store the inputs. We just need one variable and keep changing that variable with a new user input. So in this case, we will follow a counter control repetition here. And then how we do this? First, we will set the total or the sum to 0. And we set the counter to 1. And while the counter is less than or equal to 10, we will get the user to input the grade, and we add the grade to the total or the sum, and then add 1 to the counter. And we repeat it until we hit this condition. And after that, we set the class average to total divided by 10, and we print the class average. This is how we can work out the pseudocode. Okay? Now, with this pseudocode, how can we implement in C? So, if we set a total 0, a counter to 1, then what does it mean? We need to declare these two variables and assign a value to 0 and 1 to it, right? So that's why in the first chunk of the program, we will start with setting up the grade and the total and the average here. So total and average here will be set up. And then now we need to assign value total or sum to 0 and counter to 1. Okay? Now, next step, we need to set up a while loop here. So while counter is less than 10, we loop 10 times, then we printf, enter grade. So we prompt the user to give us an input, right? After they give us an input, we scan and we store into grade. So every time, in this way, every time they give us a new input, we will store it into our variables. And remember, last week we already learned that whenever we assign a new value to the memory slot, it will store the latest value, right? It will erase the previous value. So with that, we will scan the user input and store it in the variable here. Then now we will add that new value to the total. and then we increase the counter. You see, the way we control the loop is using this. Every time we increase the counter, so that at some point of time the counter will hit 10 and become greater than 10, and the while loop will stop. That's how we control the repetition and don't make it infinite. Okay? What does an assigned integer mean? Yes, previous lecture we already said in assigned integer means non-negative integer. Unequal. Okay? Now, after we do this for the while loop, this means that every time we increase the counter by one, my question right now is, when does the while loop stop? If you read this one, when does it stop? When does the while loop stop? No, it will stop at 10. No, if the counter reach 10, it will not stop. Look at this condition. If the counter equal to 10, this condition is still true and it's still executed, right? Only when the counter hit 11. Now, it's up to you to make it 10 or 11 equal here. It depends on the starting of the counter. If the counter start from 0, then it will be 10 here. If it start from 1, it will be 11 here, or equal to 10 here, because the first already started at 1, you already started at 1, you already started to count at 1. So you need to include number 10 in your condition. Okay? So for me, it's very easy. If you make it easy, you just make sure to count yourself. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Then 11 is wrong already. So you need to set the condition so that when the counter is hit 11, this condition become wrong, becomes false. That's it. Okay? So different programmer have different way to set this starting point, but the starting value need to be tally with the condition here to make sure that the loop only run 10 times. I can start at 10 also, but I can change this one to 20, right? Doesn't matter as long as the number of repetition I need to run is only 10 times. So that's the meaning of counter control. But I usually advise is, because this one is from a textbook, I don't want to change the result from a textbook, but usually what I do is I use this one 0, and I change this one into less than, or otherwise, easy for you to understand also, you can still keep this one 1, but you will change this one into less than 11. Okay, also okay, give you the same result. Okay, now, you only need to understand that with this condition, while loop only stops when the counter has value of 11. That's it. Okay? And it will run for 10 times. And after that, after the while loop stop, we need to do the remaining action here. We need to set the average class to total divided by 10 here. So basically just assignment operation, and then print out the class average. So we bring this out. Okay, can we quickly do this one in code blocks? Okay, now let me put this one out. Quickly do it. So we set integer, unsigned integer, up to you, integer. So we have unsigned, integer, create. Okay, then we have integer, unsigned integer counter, because counter cannot be negative, right? Integer create, and then you have integer total, and then integer average. So in this case, we output the average as an integer. So what we do first, we set total equal to 0, right? And counter equal to 1. And what we do next, we need to set the while loop while counter less than equal 10. What we do inside, we will print f, enter. Great. I will not need to have the %f, because that is not necessary when we do we print out only one statement there, and we do the scanf. In this one, we need the %d, right? And don't forget the AND operator here, huh? Some of you forget the AND operator and I cannot assign the value to the memory. And here we have total equal to total plus, great. Okay, and then we have counter equal to counter plus 1. I'll make a error. Okay, then after that, before this, I will do, what do? I will do average equal to, average equal to total divided by 10. Okay, and bring out percentage average final class average A. Okay, anything missing? Now let's run it. Build and run. Now I have my build window here for you. So what is the first grade? You have 10, 20, 30, 40, 50, 60, 70, 80, 90, 90, and the class average. So immediately after 10 round, it will stop, right? It will not allow me to enter any more numbers because of this counter control mechanism. Okay, see that?
Prof, why your first printf don't have percentage s but still can?
Yeah, because this one I bring out a fixed constant string. I don't need a %s. When you print out a string variable, then we need %s. I will explain more in week 5 when we talk about formatting IO. So for now, it's good to have a %s. It's okay for you to put this one, or you can do this also okay. Put also okay. No worry.
Okay. Thank
Okay, so let's say if I put out this one, I take out this statement, what will happen? Now I put this statement into comment, right? What will happen? This statement will be ignored, right? And is it expected that my while loop will run forever? Let's see how it works, huh? Now see that? It will run forever and see forever. You know why? You know why? You know why without this statement, the while loop is running forever? I have keep doing this for more than 10 times already, right? You know why if we take out this statement counter equal to counter plus 1, the while loop is running forever? Because the condition is always true, counter equal to 1. Every time it's finished, it checks back counter less than 10, and the value of the counter is only 1, forever 1. And this condition is forever true. That's why we have infinite loop. Get it? So that's why I'm saying when you use any loop, make sure in the body of the loop you have certain mechanism so that this condition will be false at some point of time. Now it's nicely do it again. Okay, now let's say if I want to change it into, for example, 5 times only, then like only 5 students, see how it works. Will it stop at 5 or not? Okay, now 10, 20, 30, 40, 50, then that's it. So it allows me to key in only 5 times. You see that? So with this, the counter is used to make sure that the repetition only runs for a certain number of times. That's it. So it's very useful when you know for sure how many repetitions that you need to run. So we use a counter control mechanism. But what if you don't know for sure how many times you can run? You just run until something happens. Then you cannot use counter anymore, right? Because you cannot count. For example, you don't know how many days it takes for you to lose from 90K to 60K. You don't know, right? You cannot count how many days. You just know that you keep doing exercise until your weight hit 60. Then you will stop. Something like that. So in this case, counter, in the case that we don't know for sure the number of iteration we can run, counter cannot be used. And we have to use a different mechanism, which is the sentinel. Okay? A sentinel control repetition. So the difference is yes, in this case also because average and the counter, the number of you for raffle here, yes, same because the numbers you key in actually number student, they are the same. Okay, so for the second case when we don't know for sure how many times we can run, but we just know that we need to run until something happens, we will use a sentinel control mechanism. So for example, in this the second situation here, we don't know the number of students. We just know that the user just keep input the value until he input something different. Then we know that is a signal for us to stop the input and getting the result. So how we can run it? So in this case, develop a class average program that handle the arbitrary number of crate, okay? We don't know how many crates that we are handling. Maybe 5 for this time, maybe 10 for another class, maybe 20, maybe 100 for some class. I don't know. So we cannot count her because we don't know for sure which number we can take. Now, we need to have different solution. So the same thing here, similar to previous one. Previous one, we know for sure that we need to run 10 times. But in the second case, we don't know how many times we need to run. We need to use some kind of special signal that when the user input this signal, I will stop, okay? And for example, you know that on the crate need to be more than 0, right? So in this case, I will choose a signal as -1. So if the use, you can set the start of the counter and the end of the counter as whatever number you want, as long as you make sure that the number of runs is 10 as intended. Okay. Now back to this. So we have the second scenario here is we don't have the fixed number of runs. So we assume that if the user enter -1, then the program will stop getting input and will start to calculate the average. Okay. Now, so this is a solution idea. So I will use a -1 as a sentinel value, and if the crate is equal to -1 here, I will stop the input and I will calculate the average and export out. So in this case, I will not use a counter as a control mechanism anymore, right? I will use a special value, and that special value called sentinel variables or sentinel control. Okay. So I will show you the development process. You can go back and review it again. So basically, the first level of refinement is I would say that I will need to come kind of define variable, and also I need to have input, and then I will calculate the print out the class average. So this kind of first refinement or problem analysis. It's a very high level. Initialize the variables into certain starting value so that I keep changing the value, right? And then from that, I can calculate getting the input, and I'll calculate the sum and then count the quiz. Great. And then with this high level starting point here, I know that I need to do this 3 steps. I need to break down into more details. So second round of this kind of iteration is what specific variable I need to do. So for example, I need a total number to calculate the total crate, right? I also need a count number to count the number of input from the user. I also need to have a variable to store the grade each time the user put in, right? And finally, the variable to store the average of the class. And then from that, based on this analysis, I know that I need to initialize only a total to 0 and then also counter to 0. Because before the user input anything, there's no grade input yet, so that counter should be 0 and total is also 0. Okay. Now the second, we get the input and calculate the sum and get the count. So same thing, we need a repetition structure, and then we use a sentinel value to store the input and compare with that special value. If the input is similar to that special value, then we stop the while and perform the summation and taking the average. With this, we convert into this process. So first, input the first grade. And then when the user says not yet enter the sentinel value, we will do these 3 things. Until we hit this sentinel value, we will stop. Okay? And lastly, we will calculate average, and then if the counter is not equal to 0, because it may be happen in the case that in the very first iteration, the user already entered the sentinel value, and then there's no actual valid value key in, we cannot calculate any average yet. So we need to perform the check before we do the division. Okay? So this is the idea, and that's why we call finalization. So this is still algorithm level. It's not a pseudocode yet. So we need to convert this one into pseudocode. So from here, then we convert to pseudocode. So here, this one will be initialized, and on this one will be put into a nicely format and low-level statement like this in pseudocode. Now, after this, from the pseudocode, we convert into C code. Similarly, right? We start with on the variable setting up is done in the beginning of the program. Then here we will start to do the initialization using the assignment here. Then getting the user input. Okay, input the first grade, set the first grade into the grade here. Then we start the while loop with this statement here, while equal to, in this case, we will use -1 as a sentinel value. It means that whenever the user enter -1, we will terminate while loop and we escape it and we'll do the rest. Okay. After that, we will check with the counter. So within the while loop, what we do, similar to the previous example, we will take increase the total, also increase the counter. And then continue to get, this two statement is important because we need to continue to get the user input, right? But if we don't do this, the user cannot re-input a new value. So we need to include this two in the while loop to continue to get a new. Then after we finish the while loop, we get out to check whether there is any valid grade entered by the user or not. If yes, then we do the average. If not, we will output the error, and that's it. Okay, so let's revise the previous example into counter control. Okay, so counter control statement here. So I will put on this one Ctrl+C first, because this one is a counter control now, so that you can see the difference between counter control and sentinel control. So this, whatever in the comments here will be the previous case when we know for sure the number of runs or repetition that we need. The second case we don't know yet. So what we do, same thing, we set up this one, but in this case counter equal to 0, not 1, because we don't have any input yet. So after we do this, we have actually finished initialization already. Have already finished the initialization, right? So what is the next thing we do? This one is finished initialization. So the next thing we need to get the user input, right? So what is the thing we do here? We get these two out, copy and paste. Okay? No worry, we will format it later. Okay? Now, we finish getting the first grade and set the first grade to this input. Then the next thing we need to do is we need to start a while. While grade is not equal to -1. So the outcome of this statement will be true or false, right? Add grade to total. So total, again, the same thing here. Okay? I will format it again. Okay. And then after this, we need to get a new input, right? So we need to get new input into this, inside the while loop also. That's it. And after that, what we do, after we finish it, we need to do the checking, right? Check if counter is not equal to 0. And what do we do? Average equal to total divided by counter. And then we print f, right? In this case, I print f %d first because I didn't change the type of the average yet. So I have %d, and I can add in I can bring down this one. Actually, I can copy this one down. All right, else print f error or no input rate. Up to you to put any message. That's it, and return. Okay. I make a simpler version than this. Okay, so that's what you see here. Here they define the average as a float number. But if we want to continue with the integer, doesn't matter. Okay. Now with this, let's run it to see whether how many we can run. How many round that we can run. Now this is how it looks like when you run the program. Let me type it inside here. Okay, you see so input grade, for example, 10, and then 20, and then 10, and then now I have 2 here and -1. If I enter -1, it hit the sentinel variable, right? Then it will escape, and the average is 13. Now, let's run again. If I hit -1 in the first round, what will happen? If I enter If enter the sentinel value in the first round, it means there's no valid grade input at any point in time, right? The first time there's no valid grade and I escape everything. Then it will say that no input grade because counter equal to 0. That's why it will print out the message here. Okay, now I pause here. Any question? Sentinel control mechanism is a bit tough to understand. Okay, so sentinel value is up to you to define between the program and the user. So usually it should be something that meaning invalid input. For example, in this case we use -1 because usually grade cannot be, it can be any number from 0 to 100, right? So that's why we put -1. But up to you if you want -2. And in this case, I will set it -2 here. But it's better to display the message clearly here so that the user know which value to terminate. Okay, so usually when we need to do like this, so the user know for sure which one is the sentinel value. So what if the user input -2, -3, or not -1? If you don't specify as unsigned grade integer for grade, it will count. Also, try it. If I don't put an unsigned grade, right, what do I do? It will calculate inside of the result also. And let's say let's run it. Because it's the program is still considered as a valid result, right? Even 120 is still a valid result. Okay, like for example, I put -1. You still consider as a valid input, right? Now I put 20 and then -2. So what? And it will calculate the average. The class average is 9 because 20 and then plus -1 is 19 divided by 2, 9. Okay, that's how it works. So usually we will make sure we will include the if statement inside with the while loop to ensure the correct input from the user. So when you know the if statements, you know the repetition already. Now it's time for you to combine them together to check whether the user input something valid or not, and whether it is a sentinel value or not. Okay, so I pause here. Any question so far? So Jonathan has 2 questions. Average is usually a decimal, so it's better to declare some floats. Yes. So as I said, declaration of variables is up to the programmer. So you can declare a float, you can declare as integer, up to you. Even for grade, because usually your grade can be 64.2, right? Can be like that also. So up to you to have integer or float. It is better to declare on variable to be unsigned. This depends. In this particular version, yes, grade, counter, sum, all will be unsigned because there's no negative value. Okay, so unsigned or not. So to put it shortly, the type of the variable or variable types is really depends on how do you design your program. All right, any questions so far? So clear, right? My suggestion, go back and practice. Because sentinel control variables or sentinel control mechanism is a bit tough for someone new to programming to get it. Okay, now some using a float point. If you notice on the example, in this case, right, in the example from textbook, in the textbook, we use float in this case, right? Float for average, and in order to print out a float number, instead of using a %d, we will use a %f. And the .2 here is for us to control the number of decimals we want to print out. So if we want to print out, for example, 20.24, then there are 2 decimal places that we want to include, right? So we put .2. So if we want to include only 1, so we put .1. But if we don't put anything, by default, float will give us 6 number behind that. Now let's change it. And then why we need to have a cast here into float here? Because because total in the integer, counter an integer. So we need to cast the result back to float, to convert from integer to float to make sure that the average is a float type. Okay? So this is something that you see from the slide because that's one from the textbook. So let us try this one. So I change it to into float and do this. And in order to do this, I will do this float. I will cast it like this. Now I will have this, and this one is not percent %T, percent %F. Should be a percent %F because I'm handling a float type. Now I run it. Let's do twos only. There's two only, for example, 20 and 30. So average will be 25, right? So I put in -2 to enter. So because I don't specify any number in my put here, and in my number and any number of decimal point in my printf, right? It will bring out 6 digits here for us because this is the default precision level of float type. Now, if we want to have only 2 decimal place, then we can put it here with 0.2. If we want only 1, then we put 0.1. Up to us. So this is formatted output that we will learn in week 5. But for now, for you to understand the code in the textbook, I just explain a bit more. So back to example again, 2 input. The result will be 25.0 because I define 1 decimal place here. Okay? -2. See the result 25.0. I'm running out of time, so we still have a big chunk of things to cover. Okay, so for this is the using float in our program, and this one will be covered in more details in week 5. Now let's move on to the last section of today's portion of today's lecture is the operators. So last week you already learned about arithmetic operators. You learned about equality and comparison, right? So today we'll learn about something new. First of all, assignment. So assignment is for you to assign values to a variable. You learn this, you see this many times already, but this side has a meaning of that. A name of that is assignment operator. Is to assign a value from the right to the left. That's it. Assign 5 to x, okay? And this is a syntax. Remember, it will evaluate the equation on the expression on the right hand side first and put it into the left hand side. This is how it do. Okay, you see it already. The other way for us to write this is also x plus equal to 5. So this is assignment is for us to increment by 5. Okay, so this is another way for us to write this statement. Instead of writing x equal to x plus 5, we can write x plus equal to 5. It means we will increase x by 5. So these are the assignment operator for us. A plus, minus, same things, we can write this way. So it means that c equal to c plus 7, d equal to d minus 4. So this is how it can be understood. So if you are not very familiar with this, you can write by this statement first. Later on, you will need to slowly try to use on this because you may need to understand code in this format because a shorter way, okay? But the meaning will be the same. How do you learn this? Yeah, sorry, you need to memorize this. But the meanings of each of the operators here. Now, next will be the increase and decrement operator. So plus, plus, and minus, minus. So the first thing is we call pre-increment or pre-decrement. And then the second portion is pause, pre and pause. There are 2 types. So pre means that we do before we do the next thing. Pre means that we assign a new value, we increase the value of that variable by 1 before doing the next expression. And then the pause is meaning that we do it after. That's it. Pre means increase or changing the value before doing the next, pass it before generate the result and pass it to the outer statement or the next statement. The pause is we pass the current value first and then we implement the operator. That's it. So let's take example here. For example, this one is for this is the pause decrease, right? Pause increment. C plus plus is after, right? So it's a pause. It means that with this, we will do the printf with the current value of C first. Sorry, I go back to this one first. Maybe I'm jumping too too fast. I assume that you'll go through this program already. So let's get back to this program. So let's say I have a very simple program like this. We have a C, and first we assign C with value 5. So this is assignment operator, right? So after this operator, this statement C has value of 5. Now, if I print out C value, I will print 5. Okay? Now, the next statement, printf C++. What does it mean? I still print out 5, and then I will increase C by 1 because this is a pause increment. It will pass the value to printf first before it increase. All right? And after this statement, C will become 6 already because of this operator, right? Then after that, we print f again. C will take the new value, which is 6. That's why we print out 6. Similarly, we have decrements, also the same thing. We reassign the value to C as 5. Print out C also 5. But now we have the pre-increment here. We print, but this is pre. Pre means we increase the value before we print. So increase 5 into 6 first, and then we print it is 6. And then because the current value is 6, the next printf will print also 6. Okay? And this is the result. Trust me, if you try this one at home, it will have the same result like this. So the key thing for you is pre. It means that you increase or decrease the value before you pass the value out to the next statement. Pause is mean that you pass the current value out first, and then you change, you increase or decrease the value. That's it. Now, that's it for today. So I pause here. Any question so far? I have C. If I input C, integer C equal to 5. Yes, the two statements are the same. Actually, the second statement is a combine of two operators. The first operator is C, integer C, and then second operator is assign the value 5 to C. So usually if you want to start initialize and declare in the same time, we can write in the short form integer C equal to 5. Jensen, that's a question from Jensen. So I pause here. Any questions? So in summary for today's lesson, we already know about algorithm, testing content. First of all, in order to write any C program, you need to have a solution for it. It means that you need to know how to solve it yourself first. You cannot write a program. You cannot teach a computer to solve any program if you don't know how to solve it. Okay, so you need to solve it step by step, and your algorithms will need to be a step-by-step instruction to your computer. Now we use pseudocode and flowchart so that other can read our code easily. Our solution easily. And pseudocode need to be able to be in the level of detail so that it can convert line by line to a C code. That is a requirement. Okay. In second thing that we learned today is control structures. So we have sequence. So structure default, we don't need to do anything. By default, C program will run top down, line by line. But if we want it to run differently, we can use if statement for selection or branching or making decision. If we want to make it run repeatedly over sometimes, we can use while loop. For loop, do while, do for and do while we will learn next week. So today we learn while loop, and we know that we have two mechanisms to control the repetition numbers so that we don't go into infinite loop, right? We don't want it any case in your program. We don't want an infinite loop. So we need to use a counter to control the number of runs, or we can use a sentinel variable to control the termination condition. Okay, and then we also learn about two things: assignment, which is very familiar to you, and second is the increment or decrement. The key thing for you to understand the pre and post operation. Okay. So far, any questions? We have about 7 minutes until the next class, I believe. So next week we will learn switch, do while, and for. Also continue and break together with do while, everything's here. So and then we can finish the C control structures. So go back, practices, especially try to run the while loop manually. It means that you run out, draw out a table and check the iteration. What happened within each iteration. So it's the best way for you to understand the while loop. Okay, that's it for today. If there are no further question, I'll see you next week. Sim SB